AI research this week points to a shift. Better models are not enough. Their reasoning has to be structured, cross-checked, and selectively rewired. New results show that adversarial teams of agents can expose flaws in technical papers, that GPT-5, 4, and Anthropic Sonnet 4.6 can produce statistically inconsistent answers that still sound plausible, and that spectral editing can improve exploration and model merging without retraining. Together, this points toward AI systems that audit themselves, reason from subgroups upward, and preserve useful capabilities instead of averaging them away. Let's explore the first paper. Can LLMs perform deep technical comprehension of computer architecture papers? The paper introduces Gauntlet, an open-source pipeline for deep technical comprehension of computer architecture papers rather than surface-level summarization. Developed by researchers from the University of Wisconsin-Madison and NVIDIA Research, Gauntlet assigns 5 independent reviewer agents covering microarchitecture, workloads, simulation tools, and paper-specific specialties to analyze each paper, then uses an adversarial synthesizer to preserve disagreements and produce a structured critique of the mechanism, key insight, evaluation, and hidden assumptions. Using Claude Opus 4.5, the study evaluated papers from ISCA 2025 and HPCA 2026 against analyses written by 10 graduate researchers. Human evaluators preferred Gauntlet in 15 of 20 comparisons. Its mean total score advantage was 4.2 points in one round and 3.6 in the other on a 25-point rubric, with the strongest gains in critical rigor. A 98-paper ablation, judged blindly with Gemini 3.1 Pro, showed that the full pipeline beat a strong single-persona agent on 96% of papers, isolating adversarial synthesis as the main source of improvement. However, humans still won when Gauntlet made a confident technical error, explained mechanisms without teaching them, or listed weaknesses without prioritization. The authors therefore position Gauntlet as a first-pass triage and teaching aid, not a replacement for expert reading. Its central contribution is the architecture of independent, domain-aware perspectives, followed by disagreement-preserving synthesis. Let's explore the second paper, Partition, Prompt, Aggregate Statistical Self-Consistency in Language Models. Researchers from the Max Planck Institute for Intelligent Systems, ETH Zurich, Ellis, and the Tübingen AI Center test whether language models behave like coherent conditional probability estimators. Their method uses binary conditioning trees. Models estimate distributions for increasingly specific subpopulations, then researchers recombine those estimates with the law of total probability and compare them with direct population-level answers. On the 2024 American Community Survey, covering 8M individuals, this reveals the macro fallacy. Subgroup estimates aggregated upward are often more accurate than direct aggregate prompts. For example, GPT-5 at 4's ACS income alignment error falls from 0.14 at the root to 0.03 after level 2 aggregation. The authors also introduce reference-free split consistency and order consistency tests, evaluated at tolerance 0.02. GPT-5-4 achieves only 0.33 split consistency, but 1 order consistency on the ACS income task, while Anthropic's Sonnet 4.6 reaches 0.7 and 0.9 average split and order consistency on 5 world values survey questions across Canada and Indonesia. The failures generalize to opinion modeling and synthetic forecasting and do not systematically disappear in stronger models, including GPT, Grok, DeepSeek, and Qwen systems. A lightweight micro to macro prompt, which asks models to reason through subpopulations before answering, partially recovers the benefit. Qwen 3. 6+ improves over direct prompting on 83.7% of global opinion QA cases. The paper argues that statistical self-consistency is a distinct, unsaturated evaluation axis, complementary to accuracy and human distribution alignment. Let's explore the third paper, Spectral Rewiring for Exploration, Purification, and Model Merging. Researchers from Tsinghua AIR and ByteDance Seed propose subspace-aligned rewiring, or SAR, a training-free method for editing reinforcement learning updates in large language models. SAR first extracts a low-rank component from the dense update, then projects it into the pre-trained model's singular vector basis, producing a rewiring matrix whose off-diagonal terms reconnect latent capabilities for compositional reasoning, while filtering off-manifold directions that cause exploration collapse and domain interference. Across deep-scale R, Polaris, and Olamo, 3, 1, 3, 2b, think spanning 1, 5b to 32b parameters, SAR preserves more than 99% of peak reasoning performance with as little as 0.58% of total parameters. On AMI 2024, with 256 rollouts, it raises solution coverage to 86.66%, compared with 83.33% for full RL, showing improved high-K exploration without retraining. On an in-house coding model, a top 1% spectral projection improves 6 of 7 agentic coding benchmarks, with a plus 2.52% average gain. In MixRL, SAR raises live code bench v5 from 67.61% to 69.09%, while maintaining mathematics and instruction following. For math code expert merging, it achieves 43.44% AMI AVG at 32 and 32.25%, live code bench AVG at 8 at the 1.5b scale, exceeding the best individual experts simultaneously. The results position spectral alignment, rather than low-rank compression alone, as the key mechanism for purification, exploration, and cross-domain model merging. That's a wrap on today's AI paper highlights. Thanks for watching.